Good morning, everyone. Today, once again, we are with each other to study mathematics as our first chapter is running. So, we have done our 2 exercise already, and I hope that you have completed your homework. Yes, and after this video, I will send you the solution of your homeworks also. So, today is 17, and our chapter name is Real Numbers. In this lecture, we are going to prove root 2, root 3, root 5, and in general we can say that if P is any prime, then root P is an irrational, right? So, what is the meaning of this statement? The meaning of this statement is that अगर हमारे अंडर रूट में कोई भी प्राइम नंबर आता है तो वो हमेशा इरेशनल होता है. सो फॉर दिस यू मस्ट रिकॉल दैट व्हाट आर इरेशनल नंबर्स. Irrational numbers are those which cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Or once again I am telling you what is irrational number. Non-terminating and non-repeating integers are known as irrational number. For example, root 2, root 3, root 15, pi, minus root 2 upon root 3, 0.1011, 0111, 000, tetra 1, 0 and so on are the few examples of irrational numbers. Now, before proving that these are irrational numbers like root 2, root 5, etc., we have to prove a little part of fundamental theorem, which is based on fundamental theorem, which we have already studied. Theorem number 1.3. It says that let P be a prime number. P be a prime number if P divides A square. If P divides A square, then P divides A, where A is a positive integer. What he is trying to say, अगर हमारे पास कोई P प्राइम नंबर है और वो किसी पॉजिटिव इंटीजर के स्क्वायर को डिवाइड करता है तो वो उस पॉजिटिव इंटीजर को भी डिवाइड करेगा. बिफोर अंडरस्टैंडिंग दिस थ्योरम आई हैव एन एग्जाम्पल. 30. What we have studied in fundamental theorem, that every composite number is having unique factorization of primes, right? So what is the prime factorization of 30? 2 into 3 into 5. 2 3s are 6, 6 5s are 30, right? So let A is equal to 30 and any prime number out of these three be P. So I am taking 3 as P. What will be the square of 30? I can write 30's square as 30 into 30. लिख सकते हैं. तो इसके prime factors into इसके prime factors will be common, isn't it? Because factorization is unique. So we cannot take any other integer because this is the uniqueness of fundamental theorem, right? So if 3 is dividing square of 30, here 3 is the factor of 30 square, 3 is dividing, and this P was in the factors of 30 itself. Therefore we can say this P will divide 30 as well. So this way we will prove this theorem. So now start the proof of the theorem. Let A be a positive integer whose prime factors are P1, P2, P3 and so on up to Pn. कोई भी n prime factors हो सकते हैं. और by fundamental theorem of arithmetic this factorization is unique. So A square के जो factorization होंगे वो उसके मल्टीपल में ही आएंगे, राइट? सो इनमें से कोई एक prime number है which is p divides a square which is given to you, which is a prime in the factorization of a. Because uniqueness of fundamental theorem says that कि ये p a के factors में भी होगा, so therefore p divides a as well. So this is proof of the theorem. Now on the basis of this theorem we are going to prove our next theorem, which says that root 2 is irrational. Such kind of question we are going to prove with contradiction. Contradiction means हम पहले से ये मानकर चलते हैं कि वो वैसा नहीं है, मीन्स हमें प्रूव करना है रूट 2 इर्रेशनल है, लेकिन हम मान के क्या चलेंगे कि रूट 2 इज़ रैशनल, और बाद में हम ये प्रूव करेंगे कि वो रैशनल नहीं था, हमारी अजम्पशन रॉन्ग थी, राइट. सो लेट्स रूट 2 बी अ rational number. And what are the rational number? By the definition we know that which can be written in the form of p upon q, where p and q are co-prime. एक बार फिर रिवाइज करा देती हूँ. What are co-prime? Co-prime numbers are those which don't have any other factor than 1. मीन्स जिनका HCF 1 होता है, जिनका 1 के अलावा कोई भी कॉमन फैक्टर नहीं होता, and q is not equal to 0. This is the definition of rational numbers. So as we let that root 2 is rational number, therefore root 2 is equal to p upon q. Now by interchanging their position, cross multiplication, root 2q is equal to p. Now squaring both sides, we have root 2 का square is 2, q square, p square, right? And here we got this. By dividing p square we are getting q square, so this implies that 2 divides p square, and by last theorem we can say that therefore 2 divides p also. अगर 2 p को divide करता है तो we can say that p is the multiple of 2, right? Got it or not? भाई आपको पता है if 2 divides 6, so 2 divides 6, so 6 is the multiple of 2 or not, isn't it? So 2 divides p, therefore p is the multiple of 2. So I can write that therefore p is equal to twice of r. Let r be any integer. Squaring both the side, p square is equal to 4r square. From first we are substituting value of p square in, from second we are putting value of p square in first. So here we will get 2q square is equal to 4r square. 2q square is equal to 4r square. q square is equal to 2r square. 2 से 2 cancel हो गया. So we are saying that 2 divides q square here. So by last theorem 2 divides q itself. So 2 p का भी कॉमन फैक्टर हो गया और q का भी. p और q दोनों का कॉमन फैक्टर हो गया, जबकि हम क्या मानकर चले थे कि p और q को प्राइम इंटीजर्स हैं जिनका कोई कॉमन फैक्टर नहीं है. Therefore our assumption is wrong. So root 2 is not a rational number, it is an irrational number.